Okay, our new topic for today is all about binary search trees. In one of the lessons, on this topic we have expression trees. The next we have tree traversal. Okay, so we'll be doing first the expression trees. Okay, so but before that we'll have a refresher course about binary search. Okay, so we have an example here, binary search. This is the list of our array. Okay, so on the list, as you can see, we have random numbers, but the random numbers are already in order. Okay, so which means this list is ordered list, an ordered list. Okay, so our search string is 22. So we're going to find out if 22 is exist. No, is exist in the list. Okay, so all you have to do in the binary search, you have to find the midpoint. Okay, on your midpoint, you check if your string, your find string or your search string is less than. So which means you have to check on the left. If your midpoint is greater than the mid string, you have to check on the right. Okay, so because your order list is ascending order. Okay, so check. Is 22 less than the midpoint? If not, you have to proceed to check on the right side. If 22 is greater than on the midpoint, if yes, so you have to cut your array. Okay, starting from the midpoint to the next key element. Okay, in this case, we have 17 to 37. Okay, so all you have to do is, again, so find the midpoint in this key elements, no? 17, 19, 22, 25, 27, 28, 33, and 37. So, so find the midpoint. So then check if the midpoint is less than, okay, to the left of your midpoint. If the search string is less than to the left of your midpoint. Okay, if yes, because 22 is less than 25, if yes, so then we cut again. So we started from the 17, then next up to before 25, so which means we have 3 key elements left. Okay, so on that element 17, 19, 22, so we have only 3, so we'll have to cut or divide, now find the midpoint. So the midpoint now is 19. Okay, on your midpoint, you have to check, is 22 less than 19? So if not, proceed to the right. Is 22 greater than 19? If yes, so then you have your remaining key element. Okay, in your key element, which is because this is only one element, so which is, if you check, your search string is 22 is less than or equal. If not, if it is equal, then you find your string. Okay, so imagine that we only have 1, 2, 3, 4 operations. Then you finally find your string. But if you're going to do it using sequential search, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 operations. Okay, if you want to search using sequential search. So there are at least 10 operations. Whereas on the binary search, you only have 4. So that is a very good or very fast type of searching. Okay. So we have here also an example of binary search, like in the hierarchical file structure computer system, one of the common trees. Okay, in our example, as you noticed, using file structure of Windows, so you will see that there's a list of files or folders. Okay, so in a list of files or folders, you'll notice that when you search for something, then the Windows will try to search using binary search type, okay, so that it will do it more faster, okay, or sometimes it will do it using indexing, so it is much more faster compared to binary search, okay. Next, we have binary search trees. This is an example of binary search trees using in order trees, okay. So this is an example. So we have 2, 3, 5, 5, 7, 8. And in order trees, you have to place your nodes, okay, nodes on the an order type of arrangement, okay, just like what we have in this example. In the binary expression tree, constructing an expression tree, so all you have to do is read the symbols one at a time. Symbols, for example, if you are given a postfix expression, so you have to proceed from left, then going to the right, okay, postfix expression. Then we have, if the symbol is an operand, so create in one node tree, okay. If it is an operand, create in one node tree. Push a pointer to the node into the stack, okay, so that is the next step. Next step, if the symbol is an operator, this time it is if the symbol is the operator or is an operator. So you have to pop 2 pointers from stack, okay, 2 pointers. So this pointers represents the address of the root nodes of 2 trees, T1 and T2. So form a new tree whose root is the operator and whose left and right children are T1 and T2 respectively. Okay, so which means you have to form a root node, or that would be your root operator. Okay, then place your left and right children as your T1 and T2 respectively. Then push the pointer to the new tree into the stack. Okay, then after that, you have to repeat the process from 1 to 3 until the last symbol has been read and processed. Okay, so as an example, we have a string or an expression, postfix expression, AB plus CDE plus asterisk divide. Okay, so try to check. Okay, so on the evaluation part, so all you have to do is read, okay, the operand. So we have here an operand, so which means we have to push, okay, push A into stack. Okay, then next we have an operand also, which means we have to push again B into the stack. So like we have here in our figure, so this is an example. So as you can see, we have an arrow because we push A into the stack. Okay, then push B into the stack. Okay, so as you can see here, the B was pushed into the stack. Okay, next, so we have an operator. So if you encounter an operator, so all you have to do is to create a subtree. So which means we have subtree for plus created. So the figure now would be this one. Okay, so next, you have to read the next string, okay, in your postfixed expression. So as you can see here, we have 3 operands, so which means we have to push the operands into our stack. So like we have here, push, okay, push the plus symbol first before pushing the C, D, and E, okay, okay, so we have C, push, then we have, okay, we have here C, push, then we have D and E, D and E, push into stack. So as you noticed here, you can proceed, pushing operands into the stack, okay, just like an example here in our figure. So D and E was pushed into the stack. Okay, next we have the plus operator. So all you have to do if you encounter an operator is you create a subtree, okay, for the plus created. Then you have to push that into your stack. Okay, push that plus into your stack. So as you noticed here, you have an arrow here, so which means we push plus into the stack, including its children. Okay. The next is we have asterisk. So repeat the process. Asterisk. We have to create a subtree for asterisk. Okay. Then we push it back. We push it back into our stack. Okay, the asterisk. So as you can see here, we have now asterisk. Okay, followed by its subtree. Okay. Next, we have the division symbol. So this one, as you can see, we have two subtrees. So the one at the left and the one at the right. So all you have to do is put at the middle, okay? Because it's a binary tree, so put at the middle the operator, okay? So we have create a subtree, okay? We have created a subtree, then we push the division symbol into our stack, okay? So this is our final tree, binary expression tree, okay? And that's all. Thank you. So before proceeding, we have some example of that, but we'll be doing that in the next video. Thank you.